Triangle congruency time. All right, we're going to talk about SSS and SAS. That probably doesn't mean much to you right now, but that's all right. We're going to learn about it today. And your learning target is I can apply the SSS and SAS congruency postulates to solve problems. All right, here we go. All right, we have two different postulates that we're going to talk about today, and the first one we're going to talk about is the side-side-side. That's the SSS congruence, and what that says that if we have three or more sides, or not three or more, I guess just three sides of two triangles, and those three sides are congruent, then the triangles must also be congruent. So what this looks like here is if we have two triangles here and we can see that all three of these sides are congruent. AB is 4, DF is 4, AC is 7, EF is 7, BC is 6, DE is 6. All three have corresponding sides that are congruent to one another. Therefore, these two triangles have to be congruent. Okay. Now, the side angle side, that's SAS congruence, that says that if two sides and the angle formed by those two sides are congruent with two sides and the angle formed by another triangle, then the two triangles also must be congruent. Okay, and so what we see here is that we've got AB and we've got EF over here. We've got this angle right here at A, the angle here at E, and the line AC is congruent to ED or DE. That means that those two triangles have to be congruent because we have two sides and the angle in between that's made by these two sides, the angle formed by those two sides, are congruent to one another. Therefore, they have to be congruent triangles. Let's do some examples. All right, example 1 wants us to explain why triangle ABC is congruent to triangle DBC. And the very first thing you want to do when you're given a problem like this is you want to first explain what is given. What do we know? Okay, and we know we are given that line AB is congruent to line DB. And we're also given that line AC is congruent to line DC. All right, so that's the information that we're given. All right. Now now that we've laid out what we do know, what we're given information, we need to apply something that maybe would help us solve this. Okay. So remember, we've been talking about side congruency and side angle side congruency, and we can't really prove that these two angles A and D are going to be congruent, but we do know that BC is the same line. So we know that line BC is a shared line. Therefore, it has to be congruent. Okay, so the last little part here is we can then say that triangle ABC is congruent to triangle DBC because of SSS congruency. All right, so we explained what we knew, what we were given, and then we wrote down something that would help us kind of clarify everything else that we didn't know. All right, same type of deal here for example 2. It says that the diagram shows part of the support structure for the tower. We need to explain why triangle XYZ is congruent to triangle VWZ. Okay, so why are these two triangles congruent? So first, let's put down what we know, what we're given. We are given the information that XZ, line XZ, is congruent to line VZ. We're given that. We're also given that line YZ is congruent to WZ. So YZ is congruent to WZ. That's the pieces of information that we do know, okay? And we've been talking again about side congruency and side angle side congruency. And so we know we can't really clarify that XY is going to be the same as WV, but we do know something about this angle here, and we know that those are vertical angles. And so we can say that XZY, we know that angle XZY is congruent to angle VZW because of vertical angles. So triangle XYZ is congruent to triangle VWZ, and that's because of side angle side. Alright, that's it. Alright, so example 3 says that we need to show that this triangle MNO is congruent to PQR when the value of x is 5. Okay, so first let's write down what our corresponding sides are. And remember, corresponding sides, if we're talking about congruent triangles, they need to be equal to each other. Okay, and again, corresponding sides are written out in order here. So MN must be congruent to PQ. MN should equal PQ. We also know that NO should be equal to QR. And we also know that MO should be equal to PR. Mo. Alright, and if we look at those, MN and PQ, that looks about right. That should be right. NO, this little side here, should be about QR, and MO with PR. That looks good. Okay, so now all we're going to do is we're going to plug in, we're going to write in what we know. We know MN is a value of 7, and PQ is x plus 2. Okay, and if it said x is equal to 5, then all we have to do is just plug in 5 for x, and 5 plus 2 is 7. Sorry, I'm cutting it off here. That means that that is true. Okay, that side they do equal each other. Okay, and we just need to do that for each of these. So NO is 5, QR is x. Remember, Q or x was 5. And that means that checks out. 5 is equal to 5. This last one, MO, is 6. That needs to be equal to PR, which is 3x minus 9. This is going to take a little bit more algebra here. And let me move this over just a little bit. We need to plug in 5 for x. So we have 3 times 5 minus 9. And 3 times 5 is 15. And 15 minus 9 is, in fact, 6. Okay, so at the end of all of this, we can say that triangle MNO is congruent to triangle PQR, and that's by side congruency, because all 3 of those sides were actually congruent. Alright, that's it. Take luck.